Hello friends, welcome to my channel. Our today's topic for discussion is 3 schema architecture of DBMS. Before starting with the topic, I want to request you all to subscribe to my channel and please share with your friends and hit the bell icon to get latest notifications. Today we will discuss what is schema, what is 3-tier schema architecture and why it is used. So let's start. We'll first see what is schema. Schema is nothing but a structure. Okay. In DBMS, data is stored in two-dimensional structure. We call it as a table. Table has rows and columns. These are nothing but the columns and these are nothing but the rows. For example, we'll take the example of employee. Now consider employee table. The employee is having attributes employee ID, employee name and salary. We'll consider only 3 attributes over here and we will create a structure of employee over here. So the attributes will become column over here. So employee ID, employee name and salary. So these attributes are columns of employee table. So these are columns. Now we will enter employee data in this table. Suppose employee ID is 101, employee name is ABC, salary is 10,000. Employee ID is 102, employee name is XYZ, salary is 20,000. So these are nothing but the rows of the table. So here for employee ID we are entering integer values. So data type of employee ID may be integer. And for employee name we are entering string. So data type of employee name is varchar. And for salary we are entering the values 10,000 and 20,000. So data type may be float. So this can be called as a schema. So considering this overall thing, schema is nothing but structure of database. You can also call schema is description of database. This is all about schema. Now we'll see why 3 schema architecture is created. This 3 schema architecture is created to keep actual data or actual database separate from user application. Means here we are hiding the details of the database from the user applications. So which type of details we are hiding? Details like how data is stored, where data is stored, etc. So we are not providing the details of the database to the user applications. So we can also call it as a data abstraction. Abstraction is nothing but hiding details. So here we are hiding details from user. The concept of data abstraction leads to data independence. It means data is independent in the levels of the architecture. So we have 3 levels of the architecture. So these 3 levels provides data independence. So here we will discuss this 3 level architecture having 3 layers: external schema, conceptual schema and physical schema. This external schema can also be called as a view level. Conceptual schema can also be called as a logical level, and physical schema can also be called as a internal level. We'll see each of the level one by one now. The topmost level in this architecture is external schema, that is view level. This level has highest level of data abstraction. Means details are more hidden in this level. Data abstraction is highest at this level. So this level decides how data is represented to multiple users, or which user can view which data can be decided at this level. So we can take the example of irctc.in. This website provides the train ticket booking. So if you want to book a train ticket, or if you want to view the train details, you can visit this site. So there are 2 types of user in this site. There can also be multiple types of user. We'll consider only 2 types over here. The visitor, who only wants to view the train details. The visitor is the person who is not registered in this website. So the person who is not registered can only view the train details in IRCTC. But if anyone wants to book a train ticket, he has to register in this website. So we can call that person as a registered user. So registered user can book a train ticket. So you have 2 users over here, visitor and registered user. Visitor can view the train details. Registered user can also view the train details, but he can also book a train ticket. So even if you have different users over here, they will have different visualization of data. The view provided to both of them is different. Means access provided to registered user is quite more than access provided to visitor. So this external schema can provide multiple views of data depending upon multiple users. Okay. So different views are created according to different users in this external schema, or you can say view level. So multiple views are created. That's why we are calling this level as a view level. The second level in this architecture is conceptual schema, or you can call it as a logical level. This level resides in between physical schema and external schema. So what this level does, it provides the logical view of the database. What do you mean by logical view? Suppose you want to create actual database, then you have to first provide the logical concept of that database. This logical schema is provided by using ER diagram. Suppose we want to store some data. We will take the example again of train reservation. We want to store the data about the trains. What data you want to store about the trains, that will be decided at the conceptual scheme. Like suppose for train, you will store train number, train name, then you will store source, destination, departure time, and so on. You will store multiple details about the train. So we have to first create this logical view of the train. Okay, we can say it also as a design. So design shows or design provides multiple data elements in the database and the relationship between these data elements. Like for train, you may create booking. So for booking, what data you want to store? You store PNR number, booking date, and so on. So train and booking are associated with each other. So your ER diagram will capture this relationship. So we can call it as a design also. Okay. So before creation of our database, what you have to do? You have to provide a conceptual design of your database. This is done at this level, 3 level, a conceptual level. Okay. Suppose particular user want to create a booking for particular train. So what we will store? We store data about the user also who want to create a booking. For which train user will create a booking. Okay, so every detail should be there while creation of booking. So these details are captured in this conceptual design. We can call this conceptual design as ER diagram. ER diagram, you might not know about the concept. We will discuss this concept in further lectures. I will tell you in short what ER diagram is. Okay. Suppose you want to store or suppose you want to start a construction of a building. We must have an architectural plan with us before starting the construction. So this architectural plan is nothing but the design of our building. In the same way, suppose we want to create and store database in a database management system, we have to first create a model of our database. For this database, we have to create a model. This model, we call it as a conceptual model. Okay, this conceptual model is nothing but the ER diagram. E stands for entity and R stands for relationship. So entity relationship diagram you have to first create before creating our database. So this entity is nothing but the data element and relationship is nothing but the association between these data elements. So we have to capture all the data elements for our problem. We have to establish a relationship between these data elements, and this is all done at the conceptual schema level. Okay, so you can call this ER diagram as a blueprint of your database. Blueprint is nothing but the path which is followed by database administrator to create a database. So designer will create this blueprint at the conceptual schema level, and at the physical level this database administrator will follow this path to create a database. The innermost level in this 3-tier architecture or 3-level architecture is physical schema or internal level. This level provides lowest level of data abstraction. Means details are not hidden in this level. This level describes how data is actually stored in the database and provides methods to access this database. Here in this level, data is actually stored. The physical, as the word suggests, it means existence of database physically at this level. So here you can find every detail of your database. So database administrator will handle all these details of the database in this level. This database administrator will follow the path given at the conceptual schema level by the designer who have created a ER diagram. By using that ER diagram, database admin will create a database. Generally, this level we call it as a backend level, or you can call it as a backend. And view level you can call as a front end. Okay, so front end is nothing but the user interface. So front end is user interface, and backend is your database. So user interface have highest level of data abstraction. Backend has, or database physical schema has, lowest level of data abstraction. So this front end can be designed or developed by using any programming language like Java. And backend is nothing but your actual data which is handled by or managed by database administrator. So front end is separated from back end. So front end users don't know where data is actually stored, how it is maintained. This is the concept. This concept is called as data independence. This data independence concept is implemented in these 3 levels of architecture of DBMS. So hope you like this video. If you like this video, hit the like button and thank you.